Okay, recording. So I'm going to start with announcements, and these are going to be preserved in the Zoom recording. Usually I do my classroom management like announcements off the record, and then the Zoom recording is just like the lecture content. However, we have some people that are gone today and joining later, and more people are going to be, I expect more people to be watching these Zoom recordings for like their class experience. So I'm going to try to remember to do announcements. Coming up, we have our first full indoor lab activity this Thursday. So we're going to be indoors. If you have a class conflict at the start of lab, that's okay. You can come as you're able. I'll run through the directions probably at the normal time for when most people arrive. Then I'm happy to go through them again. With you guys, we'll be doing stations, talking about getting practice with our soil description techniques and practices, which we're going to cover more in the lecture on Thursday as well. So that'll be a good review. The REM 460 field trip is coming up. That's at least a handful of you guys, I think. It happens every year. It's okay. I know there's going to be a lot of people going. You don't have to let me know. I already have the list. You're going to miss lecture and lab, not this Thursday, but next Thursday, right? That's okay. Happens every year. We're going to do the second kind of morphology soil description stations. So the week you get back, I'm going to do a little creative field trip solution where we split the group in half. I take half the group out at once to go do a soil pit description, our first one. So if you miss for the 460 field trip or lab next Thursday, this is September 5th, I think. If you're gone that day, there's no out-of-class makeup. I'll just have you do those stations on September 12th in lab during the normal time. That day, you'll do the indoor lab first and the outdoor portion of it in the second half. So you probably will be busy with lab until like 5:20, the normally scheduled time on September 12th. But you don't have to do anything to make up the lab that you miss anyway. So I hope that's a good deal. Also coming up that same weekend, if you're not on the REM 460 trip, we have our own soils field trip in the soils department, Soil 456. It's called the North Idaho Field Trip. It's like a partnership with the forestry, Mark Kimsey in the forestry department. It's a 1-credit class, camping trip, learning about soils, doing soil descriptions, also a little bit of forestry. We have some spots open up recently. Some students dropped out, so
What did you say this was?
Soil 456 North Idaho Field Trip. That's a good way to get some extra soil description practice in locations that are further away, more beautiful, more exciting maybe than we can offer right here within driving distance of the Palouse. We're going up to Coeur d'Alene, Sandpoint, Priest Lake, Bonner's Ferry, that kind of area. Also, we have more extracurricular opportunities for soil description experience. Our soil judging team, which I'm the coach of, Logan's a member of. Our first team practice will be this Wednesday at 5 p.m. in the soils lab 133. We are a pretty competitive team. We've had success lately doing these soil profile descriptions like as a competition against other schools. There's usually a regional contest every fall and a national contest every spring. We've traveled really all over the country over the last 2 or 3 years, and this semester is our turn hosting a competition. So I'm the one coordinating it actually. This October, second week of October, we are having a home soil judging competition. So if you're excited about the soil description and you want extra practice with this, and maybe not the burden on your schedule of missing like a week of class to travel, we'll be doing our competition at home. So you can check it out, informational meeting this Wednesday at 5 in the soils teaching lab. And then other announcements is my research lab is usually always looking for undergraduate lab assistants. So if you're looking for a job or if you're on work study, I was asked to plug our undergraduate help opportunities. It's really a flexible job, set your own hours pretty much. And you can build experience with soil research projects and working in the lab. Let me know if you're interested in any of those things. Soil 456 field trip, soil judging team, soil science lab position. and I'm happy to share more info. So with the recording going already, I'm going to share screen. We're going to review where we left off, from where we left off last week with our master horizons. I'm going to switch back to Zoom, share. Okay, there we go. With transition horizons, so we went over all of the simple ones, right? A, B, and C. The interesting ones, the W, the L, the M, the V, and the complicated ones where we have maybe multiple horizons showing up at the same time. Common example would be an A-B transition horizon. We've got properties of the A horizon, properties of the B horizon, and some zone in between with properties of both. We could say it's the A-B with no slash. Usually this would be the color of the A, but the structure of the B horizon. There's no slash between this one, kind of separate from when we do have a slash, which means there's clearly separable characteristics in the same horizon. So another way I think about this, think back to like my freshman year of high school biology class, learned about like genetics, Punnett squares, where you have, so like the transition horizon where there's no slash, properties of both is like if you cross a red flower and a white flower and you get a pink flower, it's like you have the properties of both put together, versus if you have like a black, what is it, like a rabbit and a white rabbit that make a, not a gray rabbit, but a black and white spotted rabbit is the slash. It's clearly separable. Discrete characteristics of both would be the B/A, the B/E, the codominance genetics, or the incomplete dominance of the AB, no slash. Let's see, and now for the modifiers, right? There's even more complicating factors to the master horizons. We've got a lithologic discontinuity, two fancy words, essentially meaning a change in the parent material of a soil profile. So the way we describe that, or the way you recognize that, is if you're in a soil pit and you have two very differing textures. Like you go from something silty, smooth, clayey maybe, to something really sandy, or you go from having very smooth texture with no rock fragments to suddenly having a lot of rocks, a distinct change in the texture, or a really strong color change, more than just like the dark brown A horizon to a lighter brown subsoil, an extreme color change, something different about the mineralogy, all clues for a different parent material in the profile. And when you have that, we put a numerical prefix in front of the master horizon letter. All that means is a 2, usually. Always starts with a 2 because the first parent material is implied. So what does that mean? If this is our soil profile, we might have looked at this picture before already. I see a really smooth section up here with this reddish brown color, and then a really extreme change to lighter, more yellowish kind of gray than this reddish brown. It also looks a lot sandier to me. We've got some rocks here, rock fragments, pebbles, sand, and gravel. This is probably a change in parent material. So where we would have volcanic ash parent material at the top, and maybe something like glacial outwash parent material on this bottom half of the profile. The way we would describe this, we've got a really thin A horizon here at the surface. That's just like normal. Some kind of B master horizon in this volcanic ash parent material where we have some soil development going on. And then let's say it's a C horizon in the glacial outwash section. We put the horizon boundary there, call it a C horizon. Since it's our second parent material, we're going to add a 2 to the front. 2 goes in front for change of parent material. 2C. Yes.
A lot of the stuff that we have around here, it's like for the aioli dust, whatever. I don't remember the word about dust that settles on top of the salt.
Yes, this is similar to what we can see around here on the Palouse. Usually in our the rolling hills, like the loess parent material, usually we only have the same. It's the same lust parent material, so we don't really have a change, but we will have a chance to describe soil profiles using the number 2 here, prefix. Does that make sense why the first parent material is always implied? You don't have, when you add a 2 here, you don't have to go back and add a 1. You don't have to start describing 1A, 1B. There's always going to be something there. It's really only notable when you get to the second one, you add the 2. If we had volcanic ash over glacial outwash over like a bedrock parent material, then you would have a 3 in front if you have the third parent material. And we have some examples, maybe not that we'll see on field trips, but if you look around the monolith collection outside the lab, you can find some soil profiles that have some very high numbers of prefixes, multiple parent material events. Okay, that's the lithologic discontinuity, fancy way of saying change of parent material, fancy way of saying 2. We also have primes, which is a little apostrophe. Definition of a prime, or the use case for it, is when we have separation of like horizons due to pedogenic processes. This is just to say, you have the same soil horizon that's naturally separated due to the soil formation of the profile. This is different than a buried horizon, which we're going to talk about more today. But example of this would be if we had an A horizon at the top over an E horizon, kind of forming naturally normal, and then a B horizon. This is all fine and good so far, normal profile. And then below that B horizon happens to be another E horizon. It's the same horizon. We describe it the same both ways, that they're both E horizons, but we can't have any like numbers describing it because they're separated. We can't say it's E1 and E2, and it's maybe not like a buried horizon. So it would normally be described the exact same way of a capital E, but we already have a capital E in this profile, so we have to have an E prime to say it's the second E horizon, but it's been separated. Little apostrophe. These are not very common. Even less common is a caret. Little exponent symbol. Carets denote something that's human transported. This does not include M horizons, which we know are like manufactured materials. Obviously, those are transported there. Caret usually refers to like topsoil fill material, I think is the most common example of it I could think of around here, where it's still like normal soil. Maybe it's not a separate parent material, but it doesn't make sense, or it wouldn't otherwise make sense in like the story of the landscape or the soil profile to say, how do you have this distinct A horizon here? You can't really explain it through soil formation. The way you would explain this on your soil description sheet is with that little exponent, caret. It's human transported. For example, if it is topsoil fill material, it would just be a little caret A over like a B and a C horizon that form naturally. Prime will hopefully make more sense in the next set of slides. I have a really good example of it. And then caret, yeah, I just think of topsoil fill. It's kind of how you denote that. Questions about master horizons? Just our little catch up here, or anything else from last time? If not, we can switch to today's content, which I introduced to you in this way. Given these as clues, what could we be talking about today? That's a good guess, but not what I'm looking for. What do these two have in common? What do they make you think of?
Sorry.
Nursery rhymes? Sleep? Yeah, but why these two specifically? Same cadence. You don't even need the sheet music in, right? You sing them to the same tune, right? That's Twinkle Twinkle Little Star, Ba Ba Black Sheep. But there's the third one, a third song that's sung the same way. It's the ABCs, the alphabet song. We're talking about the alphabet today, yay! And subordinate distinctions. So before we had our master horizons that I said were easy as ABC, which maybe turned out to not be totally true. There's a little more complicated than just ABC. Today we're talking about the whole entire alphabet. Our subordinate distinctions, of course, we have more diverse options than just the master horizons. These are now lowercase letters that we put after master horizons. You can also call them horizon suffixes. I've seen some people say horizon subscripts. I prefer subordinate distinctions. Other things to know about these is that you can have multiple of them at once in particularly complicated or exciting soil profiles with a lot going on. You can have multiple of them at the same time. Certain soil master horizons will require a subordinate distinction with them. So in the last set of slides, maybe I just talked about an O horizon over an A horizon, or a B horizon over a C horizon. I should really been more specific in those cases, because O, B, and L horizons, for example, will always need to be described with a subordinate distinction. Some subordinate distinctions can only go with certain horizons. Their like options are limited. We can talk about the definitions and which ones that are either usually matched up with or like forced restricted to be matched up with, only suitable with some master horizons. And then to make it even more complicated, some subordinate distinctions are multiple letters long. Soil scientists, they said, yes, we have this whole alphabet of 26 letters to describe soil development. Started assigning letters, started realizing there's more than 26 options for soil development in the world. What do we do here? They start doubling up. We will talk about some of those. So that is to say, there are a lot of subordinate distinctions. I'm about to show you a list of all of them. You do not have to start copying them down right away. This is just to say that these are all the options. This list is right out of the field book for sampling and describing soils, okay, the little soil Bible that we have. We're going to have in the field kits. You're always going to have available to you. You go out into your jobs and do soil descriptions there ever. This will always be available to you. You don't have to memorize this or write them all down. And for that reason, like I debated how much time I even want to spend explaining these to you, because you can always just look up these definitions. But they're too important just to not talk about it all. And also I want to show them to you, show you pictures, do a little explanation. So I thought, okay, well, I'll pick just a few that I think are really the most important. That ended up being like most of them. Scaled it back a little bit too. So I ended up with a set that we can go over, probably the most interesting ones. Not all of them, of course, we will get to see here, because this whole set describes soil development all over the world. So we won't necessarily get to see the permafrost or the really interesting chemical ones. And you won't be responsible for knowing all these either. I think it'll be really clear as we go through our field trips which subordinate distinction letters will be the most common. Those would be the ones that I encourage you to be the most familiar with. I think some students showed up last fall for the first test having memorized every single letter on this list, and they were a little disappointed to realize that wasn't what I was asking you to do on the test, really. So I'm really not big into memorization. I'm more of a concepts guy. How can you think through an example that I give you, or like use logic to figure things out? Really not so much of a rote memorization thing in this class here. However, this is for reference. It's always available online, page 48 of this PDF document, section 2, page 4 of the field book. Overview of the most important ones are what we're getting into today. They're kind of they're in Paul order in these slides. if you'd prefer to have them listed alphabetically, that's what the whiteboard list is for. So those are all the letters we're going to talk about. Maybe one or two lines in your notes if you want them in alphabetical order is how we're going to go through these. But if you want them in your notes in Paul order, we can start at the top, at least the top mineral horizon, okay? That's excluding the O, we're going right for the A. And the subordinate distinction lowercase letter that we can most commonly find with A horizons is a P, I would say. The reason we're starting with P, or the reason that it is P in the first place, is because it stands for some kind of plow layer. Usually an AP horizon is found in an agricultural setting, and you'd recognize it by this abrupt boundary at some historical tillage depth. So repeated tilling action in a field over probably decades and decades, it's like constantly mixing up the topsoil to the depth that like the chisel or the disc will go down to, mixes up the soil and puts this kind of hard, clear line in between the topsoil within the tillage depth to whatever is below it. So usually in the natural forming soils world, we don't have such clear straight lines like this between horizons. That's what we call an abrupt boundary. It's really clearly separable AP horizon. Most common due to tillage. If you're in a farm field, I would be looking for AP horizons at the top. But they can also be in like pasture ground if there's compaction, cattle grazing. You can also have an AP horizon described there. Not from tilling necessarily, but if there's still an abrupt boundary from maybe a change in the structure or like a compaction level close to the surface, that can still end up being an AP horizon. Next with A horizons is the lowercase b. Usually I see it most with A horizons. It can also go with B horizons and stands for buried. The reason these are used or found in a soil profile is when you have some kind of existing soil profile developed naturally that's all of a sudden covered up by some new parent material event. So maybe a river changed course, or there's a big flood event, or wind patterns changed. You have wind bringing in silt, dust particles. Something happened to bury, or like a landslide. This soil profile got buried here. So this dark line that's kind of diagonal across this profile, denoted by the arrows, is what used to be a topsoil horizon. This is like an old A horizon. Something happened, maybe a landslide where we have new sediment that's deposited on top of the soil profile. So we still have this A horizon, but now it's not at the top anymore necessarily. The way we would describe this is the regular A horizon up here, maybe a regular B horizon below that, and then all of a sudden we get to this old A horizon that used to be at surface. We would use the lowercase b because it's a buried A horizon. We have a really good monolith in the collection. This is this one right here is right outside our soil grad student's office on the first floor, room 149. Let's say this monolith example, we have an A horizon at the surface. You have this really, it's a thin, kind of darker A horizon layer there. Maybe two B horizons, describe them as BWs. We'll get to BW later in the set. But that's this top third right here, where we have this other kind of dark brown horizon across the soil profile. That is a buried A horizon. It used to be the surface, got covered up by the top layer. So we have another A horizon, except this time the A horizon is buried. Same thing goes for these BW horizons, BWB 1 and 2. But now that same thing happened again earlier on, where we have a third A horizon in the profile. it's buried again. So I would want to say AB for this one as well, but I can't because we already have an AB horizon in the profile. You can't have two of the exact same horizon names. That's why we have the numbering system right there for BW1 and BW2. This one can't be AB1 and AB2 though, because they're not consecutive horizons right next to each other. So instead we say AB prime. Separation of like horizons. So the same kind of AB horizon due to some natural soil forming event here. It's the same thing, BWB1 prime, BWB2 prime. I think finding an AB horizon on its own, whether or not it has a B horizon with it, whether or not it repeats, is still pretty exciting. Just an AB. But defined. What do these W's actually mean though? Let's see, buried and prime, yes. Our next one's W. This one goes with B horizons. And the W stands for weak development. It would also kind of make sense to cover this one last, perhaps, or right away, because the W option is really just the backup. It's what you use when you know a B horizon has soil development, so it needs a subordinate distinction. You have to describe what kind of soil development is happening in order for that B horizon to have formed. But there's not enough development to use some other letter in the whole entire alphabet describing soil development. So weakly developed B horizon, maybe it's got the color or the structure of a B horizon that we would expect. However, there's no better letter to describe it with. Our local example, like this profile we just looked at to start with, would be of a volcanic ash parent material, relatively recent, like geologically young sediments. There has been enough time for soil development to proceed long enough to have another letter in our subordinate distinction alphabet. Usually we describe these as BW horizons. Doesn't have to be volcanic ash, but anywhere we have just a weakly developed B horizon, put that on a W. Given enough time, if you have a weakly developed B horizon, the first one that it might turn into is a T subordinate distinction, a BT horizon. This is a really common one around here. BT goes with the horizons, of course, and it stands for clay accumulation. The reason why it's a letter T, this is a little just trivia here, you don't have to remember. The Germans described this first, so they used their word for clay, tone, BTs. Clay films, super common around here, and they look like little just accumulations, spots kind of on the outside of aggregates. So they can be really hard to spot as you're just kind of training your eye to look for them. But in this example, it's like this. Looks shiny in the photo. I prefer to say clay films are like more matte in color, like they just reflect light a little bit differently. It's like a little coating, a little just film accumulation on the outside of a aggregate of the soil as it comes out. They can be harder to spot. I'm not sure how well it's showing up on the screen there, but it's this kind of darker brown, maybe purpley, really harder to spot in this example. Maybe clay films in those spots on this example. This one's easier to see. It's kind of little shiny spot there. These are also called argillans. I prefer clay films. Common in areas that get enough rain, because how these form is the clay particles themselves are like trickled down, transported down through the soil profile, accumulating in the B horizons. It's like the clay accumulation in the B horizon, and then they get stuck attached on the outside of these soil aggregates. So they're common in areas that get a little bit of rain, but don't necessarily have to be. Similar example, except On the drier side for our next horizon is the K, a BK horizon. K goes with B. It stands for calcium carbonate, easy to remember, because it's a K. What makes this one tricky is you have calcium carbonate in the profile, except it has to be due to pedogenic accumulation. If you have soil forming from a limestone bedrock paramaterial, that's also like calcium carbonate rock, that doesn't necessarily count. It has to be secondary carbonates, we could say, that are they're accumulating there rather than primary, which means they're inherited from the paramaterial. But pedogenic accumulation of calcium carbonate happens where it's dry. If you have too much rain, this carbonate can be like washed, leached out of the profile. And it looks like a white kind of chalky color in the soil. The best way to identify it is with hydrochloric acid. Little HCl dropper bottles are part of the field kits. If you put a little HCl on soil that contains calcium carbonate, has anybody seen it before? What happens?
Bubbles.
Fizzy bubble effervescence reaction. Yes. Exciting. In this example, it kind of covers the whole matrix, the matrix of the soil, with this really white kind of light chalk, dusty color. The whole soil matrix would be effervescence. It would react with HCl. You can also have like discrete chunks of it, nodules of it. These little white spots here on their own react in HCl, but maybe like the background soil does not. Looking closely at this picture, I'm thinking like right there, right here, I'm seeing some clay films in there as well, the kind of brownish, a little bit purpley color. Just a different kind of covering on the outside of the soil. Those are clay films as well. So we can double up. It could be a BTK horizon. Not so common around here necessarily, but there's plenty of places like Great Plains, I would say, that we have BTK doubled up. Yes, Riley.
So why is it a BTK and not BKT?
BKT.
Does that matter?
For you guys, no, it doesn't. Like I just talked about with the master horizons, the letter that you put first is the dominant one. That's only for the capital letters. The subordinate distinctions have usually a specific order. So just because it's BTK here doesn't necessarily mean the clay films are a lot more present or common or dominating compared to the carbonates. It's just like a presence absence thing. So there are certain rules. I don't fully know them myself. I just know what feels right, what makes sense. Just based on the ones we've covered so far, T, the rule for T is usually that it always goes first. And then the rule for B is that it always goes last. That's about all I could say anyway about the ordering of subordinate distinctions. But for our class, even for like soil judges themselves, as long as the letters are correct, it doesn't matter what order they're in for our purposes. Good question. Yes.
I was going to say, in order for a BTK to occur, wouldn't you need like seasonal dryness?
Yeah. Usually it's in like an overlap zone where you'd have BTs higher in the profile where it receives more water, BKs lower in the profile where it's relatively drier, and then at some kind of overlap zone, a BTK might form. Good question. Moving on, because we have a lot more to cover in the last 15 minutes here. Our X horizon, one moment. I think maybe not as that was a better joke last year, I think. Formerly Twitter, formerly Fragipan Horizons, maybe goes with B horizon. X stands for Fragipan. What a frangipane is means it's a really dense and brittle layer. It can be hard to dig through. Number one is that it restricts root growth, probably water flow too. Really dense, really brittle. What's interesting about frangipans is the way that the aggregates like break apart is like a explosive, like a pop. It's a explosive manner of failure. We'd say this is how we recognize them. In the field, usually, if it's not clear enough already, just based on the difficulty to dig through it. So there's really, this picture kind of, I mean, it's the best I have right now. It's not like all frangipans will look like this, or you can recognize a frangipan just from visual alone. But X is, or no, it also along with the last one we did, the K, co-occurs with clay films, really common. So BTX is how you see these described. I think that these dark spots here, not necessarily representative of frangipans, these might be really prominent clay films on their own, because a really densely or dense and brittle layer like a frangipan restricts water movement. Water flow is going to be restricted to the tiny little gaps like between aggregates, any pore spaces in the frangipane. So all the water is going to be concentrated there, which means all the clay particles that are flowing with the water are going to eventually settle out or dry out onto these like aggregate edges within these pores. So those are clay films likely in this image. What else do we have here? Limits root growth for sure. Why is it an X? Best reason I have for that is that X marks the spot where you don't want to dig. However, we do have a subordinate distinction that's at least spelled with an X, or two at least, our H and our S. Both of these go with B horizons, and more specifically, they also go underneath E horizons. Since we learned last time that E horizons have lost all of their soil, like coloring material, could be nutrients, chemical components. They've been washed out of an E horizon, maybe accumulated down below it. This kind of describes the accumulation going on. Alluvial accumulation of humus for the H and or sesquioxides for the S. So specifically our H horizon means it's solubilized and translocated organic matter. This is a little more chemically complicated than just a soil horizon that's really dark due to organic matter. You never really have an A horizon with an H subordinate distinction. You might be tempted because they both kind of mean organic matter, but the H means organic matter has been like solubilized, leached out, broken down into like some kind of humic acid, and accumulated down below it. So essentially the color of this really colorful dark BHS horizon that kind of is crazy looking up and down here in this middle section is a more concentrated, or it's received all the color from this washed out light E horizon. So H describes the organic matter or the organic material, and the S, sesquioxides, describes the chemical components here. Aluminum, sesquioxide, Al2O3, anytime you have 2 of one cation and 3 oxygen. Soil scientists might describe that as a sesquioxide, or this would be iron 3 oxide, Fe2O3. These are really common in photosols, where you have the chemical environment going on, a low pH, really acidic, maybe a lot of rainfall, maybe coarse soils, sandy soils. You have the BH, the BS, or the BHS is probably most common. See them both together in photosols. Okay, the S is really important to distinguish from this next one, our O horizon, because both mean sesquioxides. However, the O represents a residual accumulation of the sesquioxides. Residual accumulation means the oxides themselves are not what's moving. It's like the silica that's breaking down in this horizon, and that's leaving, which leaves more of the sesquioxides to remain. It requires intense weathering, like the loss of the silica. They form extremely slowly, like millions and millions of years, and really typical of tropical soils. This really dark red color is from the iron oxides presence that remain in the profile. So the BS and the BO are both sesquioxides. What's the difference, though? One way that, or so residual versus alluvial accumulation, what the difference there is. This is our first basketball reference of the semester. Okay, I'm a big fan. I'm a Milwaukee Bucks fan. I'm from the Midwest, from Wisconsin. A few years ago, I went to a Milwaukee Bucks game when they were in Portland. So it's in the Motor Center, right? It's full of Portland Trailblazers fans. Is anybody here a Portland Trailblazers fan? One. Okay. Are the Blazers any better now than they were 2 or 3 years ago? 10 years, right? So perhaps unsurprising then that the game was not very close in favor of the Milwaukee Bucks. Okay, it was a blowout. They scored like 140 points. Over the course of the game, the cheering for the Milwaukee Bucks gradually increased. So what does this mean? It's not that it's obviously because the Blazer fans are leaving the game, right? It's a blowout. They got nothing to stick around for here. Scoot Henderson can only develop so much in one game that it's not worth sticking around at this point, right? So Blazer fans are leaving, and the relative concentration of Milwaukee Bucks fans is increasing. Then it's not like Blazer fans are converting to Milwaukee Bucks and starting to cheer for the other team now. Perhaps it's that Milwaukee Bucks fans got more comfortable and confident, started cheering louder, had more to drink, maybe. But no, it's because it's like a residual accumulation of Bucks fans. It was the same amount anyway since the start of the game. However, the ratio is changing. Yes, the Blazer fans, the silica is leaving the profile here. They're leaving the Moda Center, and the Milwaukee Bucks fans are relatively more concentrated. They're residually accumulated. Alluvial accumulation then would be a simpler example. Let's say there was like a pickup basketball game going on outside with like the varsity basketball players or some like people who are really good at basketball just playing in the parking lot. They would draw a crowd. Like people would accumulate around them to watch. Versus residual accumulation, where it's just becoming more concentrated over time as something else is leaving. Okay, sorry, Blazer fans. Red from Tropical, yes.
For that one, is it just in horizons?
Is O just in B horizons?
It looks like it's all the way in the A horizon.
It's got the color in there. I do not think O is described with A horizons, but that's a good question. I'm unfortunately limited in my experience with tropical soils, really old, highly weathered oxasols. I've never seen on descriptions, though, O matched with A. It's a good question, though. Not one that we will be describing this semester, unfortunately. But okay, so this is the residual accumulation of sesquioxides. We mentioned silica, though. Where does it go? It's like leaving these horizons. It must accumulate somewhere. What would that horizon be? That's what we have the letter Q for. Q means an alluvial accumulation of silica. This one also goes with B horizons. They pretty much all do until further notice, I would say. Silica, or SiO2, right? It's a really common component of Earth's crust and all soils in the first place. They build up and they begin like plugging pores within the soil. Essentially, silica is like sand grains. These are like sand grains on a molecular scale that are kind of filling in and eventually cementing a soil profile here. So it's slow forming, not quite as slow as like the tropical one was. That would be like millions of years of development. This is on the scale of tens to hundreds of thousands of years for the letter Q. Generally slow forming, dry areas. Makes me think of aridosols, or like desert soil order. Often co-occurs with a K because this is a dry area, and also with the letter M, BKQM, our first four-letter combo here. So Q means silica. I'm going to go right into M, which means cemented. The silica accumulation has progressed so much that like the whole entire matrix is filled up, plugged, cemented. If there are any cracks or gaps, they have to be at least 10 centimeters or more apart. So the whole thing is like laterally extensive. It's going to prevent root growth. Not that there's much water in these systems anyway, but water would not be able to filter through. And the reason that, if you're saying a soil profile is cemented, you would never just have a BM on its own if you think it's like cemented with something, because you have to specify what it's cemented with, the cementing agent, which is another subordinate distinction. So it could be K, could be a Q, BKQM is maybe both of them in this case. But you can be cemented due to carbonates alone with no Q. BKQ, or our next subordinate distinction, which is a Y, which means gypsum. So I think we will resume here with gypsum next time. We can look at a really cool, our hands-on example of gypsum. And then on Thursday, so Mary Beth, our lab TA, she has a little more experience in describing working with soils in dry areas. She has some show and tell gypsum to bring in, I think. We'll look at this next time. Questions before we go? Questions online? If not, I will stop.